Now let's look at another way of explaining what's happening with the bonding and getting the geometries of these molecules. You may have noticed that we've come up with molecules that are tetrahedral in shape, but when we learned about orbital shape, there weren't any that were tetrahedral. So we're going to kind of make sense out of that. This first thing is just that we're defining a bond. A bond is when you have orbitals overlap, and it takes two electrons to make a bond. And it's pretty simple when you have just hydrogen, because s orbitals are spherical, and so we've got them close together, they're overlapping, there are two electrons, so that's a bond. Where you start getting into something new is when we look at what we call hybrid orbitals. Hybrid orbitals are where orbitals that existed before the bond recombine in order to form the bonds to another atom. So anyway, let's look at carbon. These are all of carbon's electrons, but these up here in the second energy level are its valence electrons. And so what we're going to do, and this is done mathematically, but we're going to pretend like we're taking these orbitals that it has, and we're going to recombine them, these hybrid, into a hybrid. So I'm going to combine these and get new orbitals. And when I do that, I'm going to get 4. So I've got a new kind of orbital, a hybrid. I used 4 orbitals to make it, so that's why I get 4 out. Okay, and then I'm going to have a name for this. I'm going to call it S, because it had an s orbital, and then I'll call it P because it had p orbitals, but it has 3 of the p's, so I'm going to put an exponent there. And this whole thing is the name of this type of orbital that we have. There are 4 of them, and they're called sp3. So just so we're clear, when you take one s orbital and you combine it with 3 p orbitals, you get 4 sp3 orbitals. And I will refer to these as the sp3 hybrid. They're a set of orbitals. Well, what do you think the geometry would be if you have 4 orbitals? How would they get apart from each other? And it might be like you would think. I have 4 of these orbitals, and so the shape of those it's going to be tetrahedral. So these are the sp3s, and there are 4 of them. I'm drawing this methane, so let me go ahead and add the hydrogen atoms. And the hydrogen atoms just have s orbitals, and they are overlapping. And so this right here where they're overlapping, that's the bond. Well, you can combine different types of orbitals, and I chose to combine all of the p orbitals. What if I just took one of the s's and one of the p's? And so let's see what geometries I can get from that. So if I took an s orbital and combined it with a p orbital, how many orbitals would I have in my new hybrid? And so to get that, I'm basically going to add the exponents here, because the exponents told me how many orbitals were going in. So I took one s orbital, one p orbital. I'm going to have 2 new orbitals, and those orbitals are going to be called sp orbitals. And the shape, what do you think the shape would be if you have two orbitals and they repel each other? They'll be linear. Next, if I have a hybrid that's made from an S and two of the P's, adding up the exponents, I see that I'm going to have 3 orbitals in the hybrid because I used 3 orbitals to make it. And the shape, the geometry of those orbitals will be trigonal planar. Next, sp3, I took 4 orbitals to make that, so I'll get 4 orbitals out of it, and with 4, it'll be tetrahedral. That's the one we just did. Next, I've got 5 orbitals that went into this. Adding the exponents, remember the exponents are telling me what orbitals went into that were recombined to make the hybrid. And with 5, I'm going to have trigonal bipyramidal. Last, I have 6 orbitals going in, and my geometry will be octahedral. Now notice something. The number of orbitals is very similar to the number of electron groups. So when you do these shapes, you can see that if you had 6 electron groups, this would be your geometry, your electron geometry. So it's not really the same thing, but the numbers are the same. So this is like so we've kind of already done that. So how do we take our Lewis dot structures and decide what kind of hybrid orbitals it has? You do your Lewis dot structure and you count the number of electron groups again. And then the number of groups is equal to the number of orbitals, and I'm talking about the hybrid orbitals. Okay. And then from the number of hybrid orbitals, you can get the type of orbital. Look at these types. You see how they're in order? From 2, you have to have at least 2 to make a hybrid, right? 2 to 3 and so forth. I've counted them up there. These are the only possibilities. You'll never have, like if you have 2 orbitals in the hybrid, it'll never be SD. Okay, that's not a possibility. If you have 5, it has to be these 5. If you have 4, you'll never have SP2D, say. They count up in this order, and it is a definite pattern. So if I have, remember this also works as the electron group. So if I have 4 electron groups, my hybrid is sp3. If I have 2 electron groups, my hybrid is sp.